Question 6. It is given that the integral of fx is sine x plus k cosine 2x plus c, and it's also given that the integral from limit 0 to pi over 6 yields a result of 3/4. Show that k is negative half. So the first thing, we substitute the limits in. From 0 to pi over 6 for the function fx, we get sine x plus k cosine 2x plus c over that same limit so we put the limits in. 2x is pi over 3 plus c. Notice c is not in terms of x, so there is no need to include the x substitution. Subtract the lower limits. Sine 0 plus k cosine 0 plus c. So notice that the c value will cancel out. So this gives a value of sine 30 degrees half plus k cosine 60 degrees is also half. Subtract sine 0 is 0, cosine 0 is 1 plus k. And this yields a value of 3/4. 3/4, 3/4. So working that out, you get negative half k. And this is 3/4, so half k is equals to half subtract 3/4. So k is equals to negative 1/4 times 2, which is negative half, shown. Part 2. Find fx. So fx, in fact, is differentiating this function sine x plus k cosine 2x plus c. That gives you cosine x plus 2k negative sine 2x. So it's cosine x minus 2k sine 2x, where k is equals to negative half, so it's plus sine 2x. Part 3. Find the equation of the normal to the curve at the point x equals to pi over 6. So normal, for illustration purposes, if I may suggest that a curve as this, and this point here is x equals to pi over 6. So there is a tangent over here that we can find. This tangent would have the same gradient as the curve at pi over 6. Then a normal would refer to a line perpendicular to this tangent. So this is a normal, this is a tangent. And we know that the gradients, the normal gradient times the tangent's gradient, will give a value of negative 1. So by finding the gradient of the tangent, we can also find the gradient of the normal. So we need to find the gradient of this tangent, and to do that, we take the first derivative of the function fx. So the first derivative of the function fx is differentiating this. Differentiate cosine x, you get negative sine x. Differentiate sine 2x, you get plus 2 cosine 2x. And when x is equal to pi over 6, you get negative sine pi over 6 plus 2 cosine pi over 3. So that gives a value of sine 30 is half a negative half, cosine 60 is also half 1, so that is half. So gradient of the normal would be negative 1 over gradient of the tangent, which is half, and that works out to be 2 negative. So equation of normal would be y equals to negative 2x plus c. Now we still have an unknown c, so how do you find c? Substitute the coordinate when x equals to pi over 6. What is the value of y? Y is equals to the function fx when x is pi over 6. So substitute pi over 6 into the function, we get cosine pi over 6 plus sine pi over 3. That works out to be root 3 over 2 plus root 3 over 2, which is root 3. So substitute, now that we have the coordinates, x is pi over 6, y is root 3, into the equation, this equation of the normal, into equation 1, we get y equals to negative, so y value is root 3 equals to negative 2, x value is pi over 6 plus c. So c is root 3 plus pi over 3. Therefore equation of normal is y equals to 2 negative 2x plus root 3 plus pi over 3. Okay, next question. Question 4. The equation of a curve is given. Explain with working why the curve has no turning points. So we know that at turning point the first derivative is 0. So we have to prove that dy dx cannot be 0. So we take the first derivative. So if we can prove that dy dx is not 0, then we can show that this curve has no turning point. So we use quotient rule. Keep the denominator, differentiate the numerator, subtract, keep the numerator, differentiate the denominator, divided by the denominator square. So that gives a value of (2x minus 2 minus 2x minus 1 over x minus 1 square. So it's negative 3 over x minus 1 square. So this obviously can never be 0 because the denominator is x minus 1 square and the numerator is 3. There is no value of x that can give dy dx equal to 0. Therefore, this curve has no turning point. Okay, part 2. By expressing this expression in the form of a plus b over x minus 1, a and b are constants, find, showing full working, the area of the shaded region. So let's just express this in that form. 2x plus 1 over x minus 1. We notice that the numerator and the denominator are of the same order, so we can do long division. But here, let me just show you another method to solve this. So if I subtract 2 and add 2, I'm not changing the numerator. But what I'm doing is this. I group them together, I put the negative 2 here, and the plus 1 plus 2. And in so doing, I factorize 2, 1 plus 2 is 3, I will get this. I have 2x minus 1 over x minus 1 plus 3 over x minus 1. So this will allow me to cancel. I get 2 and 3 over x minus 1. Plus. Okay. So the question, show the full working of the area. So the shaded area is defined by these two limits, and these two limits, the x value is 2 and 4. So I can actually use the big area, which is actually a trapezium, 2 to 4 on the x-axis, and this value and this value, I get 5 and 3. 5 and 3 in the y-axis. So this area subtract the area under the curve. This is 2 to 4 in x-axis. And this curve is the curve that we have. Y equals to 2x plus 1 over x minus 1. So when we solve this, we can take the area of shaded region is equals to the area of the trapezium. Formula for trapezium is half times sum of parallel sides, which is 5 plus 3. This is 5, this is 3, times the width is 4 minus 2, which is 2. And I'll subtract the area under the curve is the integral, limits from 2 to 4, 2x plus 1 over x minus 1 dx. Now we're going to use what we have solved earlier over here. So let's express that in this way. This is 8, 2, subtract 4, 2, 2 plus 3 over x minus 1 dx. This gives us 8. Subtract, integrate 2, you get 2x. Integrate 3 over x minus 1, you get 3 ln x minus 1. And you put the limits in. And when you solve that, 4 times 2 is 8 plus 3 ln 4 minus 1 is 3. This is the upper limit. Do for the lower limit, 2 times 2 is 4 plus 3 ln x minus 1 is 1. Now ln 1 is 0. So rearranging, we'll get the answer. The answer is 0.704 square units. So since there is no units given, we have to add square units. That's the general unit for area. Question 18. The curve has an equation y equals to 2 minus 3 minus x to the power 4. The point P, Q is a stationary point on the curve. What does stationary point
0
suggest? What
dy
is
dx
0?
equals to 0.
It means dy dx equals to 0. So determine the values of P and Q. So first thing first, you manipulate, find the first derivative. Dy dx, when you differentiate this, you get 0, subtract 4, 3 minus x power of 3 multiplied by negative 1. Okay, the power 4 bring down, so it's here, and then the power 4 reduced by 1 become power 3. Then you multiply by the inner function, the derivative of the inner function, which is negative 1. So what you get is 4, 3 minus x power of 3. So since stationary point dy dx equals to 0, therefore 4, 3 minus x cubed is equal to 0. That means x equals to 3. When x equals to 3, what's the value of y? Substitute into the equation, the initial equation. 2 minus 3 minus 3. So y is 2. And therefore, the values of p and q. P comma q is equals to 3 comma 2. Now, next part. Determine whether y is increasing or decreasing for values of x less than p, for values of x greater than p. So we need to find whether y is increasing or decreasing. That means is the gradient positive
Or negative.
or negative, right? So when y is increasing, means the gradient is positive. When y is decreasing, the gradient is negative. So the gradient, look at the function dy dx is equal to 4, 3 minus x cubed. Okay, A. When x is less than p, when x is smaller than 3, dy dx equals to 4, 3 minus a value smaller than 3, 2, 1, 0. So whatever it is, let's give a value 2. This will give me a value bigger than 0. And therefore, since the gradient is positive, y is increasing. B. When x is bigger than 3, dy dx, any value bigger than 3, say 4, this becomes negative. 3 minus 4 is negative 1, negative 1 cubed is still negative 1, times 4 is negative 4, so it's smaller than 0. So the gradient is negative, therefore y is decreasing. As x increases, y decreases. Part 3. What do the results in part 2 imply about the stationary point? So now we have a situation where you can imagine, just for illustration purposes, may not be the actual representation. If I have a value x here before x equals to 3, when x is smaller than 3, the gradient is increasing, so the y value is the gradient is bigger than 0, so the y value is increasing. So it could be like that. Its gradient is positive. And then when x is bigger than 3, the gradient is negative. So what does this tell us about the nature of this stationary point. What kind of stationary point is this? There are three types of stationary point, remember?
Inflection.
Point of inflection and
The positive one.
it could either be a point of inflection or a maximum point
Minimum point.
or a minimum point. So what is this?
Maximum point.
This is a maximum point. Part 4. What is the value of d2y dx squared at the stationary point? So for maximum point, we would expect, what do you expect for the second derivative?
More than 0.
It should be less than 0.
Less than 0.
The gradient is getting smaller and smaller and smaller and smaller and smaller. So the gradient is decreasing. The gradient of the gradient function should be negative. So let's see, d2y dx squared. dy dx is here. So d2y dx squared, well, 3 minus x squared negative 1. So you get negative 12, 3 minus x squared. Now take note, you have a square term here. What does it mean? A square term means what kind of value a square term would you expect? Square is always what? We're dealing with real numbers here, real values, real answers. So square is always deemed as positive. Yes. So when you have a positive number, this is positive, multiplied by a negative 12,
Be negative.
you will surely get an answer that is
Less than 0.
less than 0. Exactly what we expect. You got it? So what's the value of d2y dx squared? So the value of d2y dx squared is actually when x is 3. Now if you look at this, we expect d2y dx squared to be smaller than 0 for a maximum point. But the thing is, when we substitute the values in, substitute x equals to 3, we get d2y dx squared to be equals to 3 minus 3 squared, which is 0. When the second derivative is 0, it doesn't really tell us anything much. It could be inflection point, it could be maximum, it could be minimum. So definitively, if the second derivative is a positive, it is sure a minimum point. If the second derivative is a negative, it is sure a maximum point. But if the second derivative is a 0, it is ambiguous. So you have to carry out the test based on part 2 to know whether it's a maximum or minimum. Okay? Does that clarify? Question 21. The curve has a minimum point M. So if I may, just for illustration purposes, draw a curve. There's a minimum point, we call it M, and this minimum point has a value of x1 and y1. Show that the x coordinate of m, which is x1, satisfy the equation x squared, no, x cubed equals to 9. So we have the function plus x. It's a minimum point. So minimum point means first derivative is equal to 0 at point m. So let's find out what's the first derivative. So when we put it in, we differentiate, we get negative half times 6, and this is x to the power negative half minus 1 is negative 3 over 2, then plus 1. Can you see? And that works out to be x to the power of 3 over 2 plus 1. So at m, dy dx is 0. So when we move this around, we get this. So x is equals to 3 power of two-third. This one multiply by two-third, multiply by two-third. Correct? So this is actually 9 square. So the question is,
The one x cubed equals to 9.
so when we put x cubed equals to 3 square, which is 9.
Sure.
Yes. Okay, part 2. Determine with working whether the x coordinate of P is greater or less than the x coordinate of M. So what is P? So we have 2 points, A and B, lie on the curve. The tangent to the curve at A and B meets at the point P. So this is a little bit tedious.
Yeah.
So there are 2 points. We need to find the tangents to these 2 points. Then we need to find the equation of the tangent and the point where they meet, these 2 tangents. The point where they meet is point P, the intersecting point. So we already have the first derivative, the gradient function. So when at point A, okay, at point A, x is equals to 1. Therefore, the gradient is equals to negative 3 plus 1, which is negative 2. At point B, x is equals to 4. So the gradient is 4, square root is 2, 2 cube is 8. So negative 3 over 8 plus 1, which is negative, is 5 over 8. So you got the respective gradient of the 2 tangents. And they're supposed to find the point where they meet, they intersect. So equation of the first tangent, y is equals to negative 2x plus c1. Equation of the second tangent is y equals to 5 over 8x plus c2. So now we need to find c1 and c2. At point A, y is 7. So equation, let's call this equation of tangent. Let's call this L1. Then the second one, second tangent, L2. So L1, 7 equals to negative 2. The x is 1 plus c1. So c1 is equals to 7 plus 2, 9. So equation of L1 is y equals to negative 2x plus 9. Equation 1. At B, y is equals to 7 also. 7. So second tangent, you have 7 equals to 5 over 8 x is 4
4
plus C2. Cancel 5 over 2, 2.5. C2 is 4.5. So equation of L2,
Y equals to 5 over 8x plus 4.5.
Equation 2. Solve equation 1 and 2. So solving equation 1 and equation 2, you get negative 2x plus 9 equals to 5 over 8x plus 4.5. So what's the value of x? So solving this, you get 1.71. And then y will be,
So
substitute 1.71 inside equation 1 or equation 2, you get a value of y.
See, 5.58.
5.58. So now the x coordinate of m. So this one, which one is bigger? X coordinate of p or x coordinate of m? So x coordinate of m gives you a value of less than 3. So can you give me the exact value
Of. So I
of
just
x value? This is 3 to the power of 2/3.
Yeah. 3 to the power of 2 third. Yeah, 2.08.
2.08. So this is the x coordinate of m. Here is the x coordinate of p. So this value is smaller than 2.08 plus smaller than the x coordinate of point m.